In this video, I'll be talking about the normal distribution. And first of all, it says here the overall appearance or shape of the data on a graph, such as a histogram, is referred to as the distribution of the data. So all that's really saying is what the graph basically looks like. What's its appearance? What's its shape? We call that the distribution of the data. A normal distribution, oops, let me change colors. A normal distribution is bell-shaped and symmetric about a vertical line through its center. That would be this line here. And so you can see why we say it's bell-shaped. It's kind of got that bell-like shape, and you can see the symmetry on each side of that line. It says the graph of a normal distribution is often referred to as a bell curve. The mean, median, and mode of a normal distribution or bell curve are all equal. So that's something that you want to make sure you know. And if you think about it, it makes sense if you think about what each of those measures mean. And then it says the shape of the normal distribution depends on the mean and the standard deviation. The figure to the right illustrates three normal distributions with the same mean but different standard deviations. So remember, standard deviations indicate the spread of the data or how spread out it is. And so you can see with all of these three curves, you have the same bell shape, but some of the data is more spread out depending on which one you're looking at here. So I just want to mention there's a lot of things that are distributed according to a normal distribution. For example, the height of men in the United States. The average height of a man is about 5'10" in the USA. And what you'll find is there's going to be a lot of men that are really close to 5'10", either a little more, a little bit less. And the further away you get away from that mean, the more and more you're going to see, well, you're going to see less people. And until you get to the extremes, on the one end, you have somebody that's 7 foot tall, that's an extreme. Same thing on the other end if you have men that are 5 foot or less in height. So that's the basic idea. So weights and heights are examples of things that are distributed normally. Break wear would be another example. Normally you can expect to get a certain amount of wear out of your brakes, assuming everything, in your brake system is working right. People that brake hard are going to get less brake wear or less wear out of their brakes. People that are real easy on their brakes are going to get a lot more time. These kinds of things are distributed with this kind of bell-shaped curve. And then one more would be IQs. All right, so down below here it says the 68, 95, 99.7 rule in a normal distribution. Well, it turns out there's some interesting facts here. 68% of the data is within one standard deviation from the mean. So one standard deviation above the mean, well, the mean is right here. One standard deviation above the mean would be this value right here, whatever that is. But it's one standard deviation above the mean. Here we're one standard deviation below the mean. And so basically anybody that's in here is within one standard deviation of the mean, and that's where 68% of our data would fall. So that's a majority of the data. Most people or most data is within one standard deviation from the mean in a normal distribution. That's what it's saying here. Okay, so next we have 95% of the data within two standard deviations. So now we're going from the mean out two standard deviations above the mean, two standard deviations below the mean. So 68% of your data is going to be within two standard deviations of the mean. And then finally, 99.7% of the data is within three standard deviations. So from here to here, you're going to have 99.7% of the data. That means on these ends, added together, there's 0.3% of the data there. And so if you have data that's more than three standard deviations from the mean, that's pretty extreme. All right, let's move on to the next slide, and we'll do basically an application here. It says, using the 68, 95, 99.7 rule, male adult heights in North America are approximately normally distributed with a mean of 70 inches and a standard deviation of 4 inches. So 70 inches, that's people that are 5'2", or I'm sorry, 5'10". So that's our mean. And 2 standard deviations above the mean. Well, 1 standard deviation is 4 inches. So if I add 4 inches, I'm 1 standard deviation above the mean at 74 inches. Add another 4, and now we're 2 standard deviations above the mean. And so our answer here is going to be 78. So one of the ways you can write this answer is as follows. Just write your mean, and we're going to add 2 standard deviations, so that'll be plus 2 times 4, which is our standard deviation, and we do get 8. All right, let's move on to part B. It says, what percentage of men in North America have heights between 62 and 78 inches? Well, before I do that, let me erase these marks. Okay, so what percentage of men in North America have heights between 62 and 78 inches? So we're going from here to here. And you can see basically at 78, we're 2 standard deviations above the mean. At 62, we're 2 standard deviations below the mean. And so we know that 95% of the data is going to fall within 2 standard deviations, and so that's our answer. On letter C, it says, what percentage of men in North America have heights between 70 and 82 inches? So that's from here to here. So 82 inches, that's 3 standard deviations above the mean. Now we can't directly get the answer here, but we know if we go 3 standard deviations below the mean, that between 58 and 82, that's 3 standard deviations, within 3 standard deviations of the mean. And we know 99.7% of the data is there. So if we take 99.7% of the data which is in there, that tells us if we take half of that, that's what's going to be in here from 70 to 82. So divide by 2 and you get 49.85%. All right, so again, let me clean up my mess here. And let's look at the next problem here. It says, what percentage of men in North America have heights greater than 78 inches? Well, 78 is 2 standard deviations above the mean. We want to know how many people are out here. Well, again, we got to get there in a roundabout way with just a little bit of thought. If you go from 62 to 78, you know that 95% of the data is in here. Well, doesn't that tell us that 5% of the data is outside of here? And so we know we have symmetry, and so half of 5% would be what we have here. And so that's going to be 2.5%. All right, let's move on to the next slide. It says scores on the GRE. I believe that's a test that you take after college. It helps you to get into certain programs to get a master's degree or other types of degree. It says just normally distributed. So again, we always should see that because that means we have this bell shape or bell curve type of shape with a mean of 530 and a standard deviation of 128. In A, it says find the test score that is 1 standard deviation below the mean. So we're going to start with our mean, and we're going to subtract off 1 standard deviation. Now you could just subtract 128. I'm going to put the 1 there. Hopefully that'll help when we get to the next one. So subtracting 1 standard deviation, that would put us at 402. So B says find the test score that is 2.5 standard deviations above the mean. So we're going to start at our mean of 530, and we're going to add 2.5 standard deviations. And so we'll have to multiply 128 by 2.5. Now the other way to think of this is we know that one standard deviation is 128. So adding two 128s gives you 2 standard deviations above the mean, and 64 is half of 128. And so this would also work. I'm adding 2.5 standard deviations to the mean. In either case, you get 850. All right, let's move on to the next slide, our last slide. It says if a set of data has a normal distribution with a mean of 10 and a standard deviation of 2, 68% of the data lies between what two values? Now the first thing you'll notice here is there's no picture for you. You're going to have to draw a bell-shaped curve. And so I'm going to go ahead and do that. So try to make it as symmetric as you can. And we're going to want to put in our mean. Now the way I think is a good way to draw these is to start by going 3 standard deviations on either side and put a mark. Because normally right around this area is where you're going to be at 3 standard deviations. Again, the majority of the data is going to be in here, inside these 2 marks. And so then you want to have 3 marks on each side for the 3 standard deviations. So on the right, you can see I have 3 marks, so try to make them evenly spaced. Do the same thing on the other side. So put your mean in, and then let's go 3 standard deviations above the mean and then 3 below. So 1 standard deviation is 2, so 10 plus 2, we're going to get 12. So 12 is the data value that's 1 standard deviation above the mean. Add another 2. 14 is 2 standard deviations above the mean. 16 is 3 standard deviations above the mean. And you can do the same thing on the other side. We'll subtract 2, we get 8. Subtract 2 from that, we get 6. And subtract 2, we get 4. And so now we have our picture, and we can go ahead and do these problems. So for A here, 68% of the data lies between what two values? Well, we know 68% of the data is within 1 standard deviation. And so that would be between 8 and oops, that should say 12. Let me fix that. All right, and then between what 2 values does 95% of the data lie? Well, we know that within 2 standard deviations, we have 95% of the data, and so that would go from 6 to 14. On letter C, it says, what percentage of the data lies between 6 and 10? Now, notice, actually, let me change colors here. 6 and 10, that's here. That would be half of this amount here. We know 95% of the data is within 2 standard deviations, so it's going to be half of that. So take 1/2 of 95%. 95 divided by 2, you're going to get 47.5%. All right, let me erase just a little bit here. So I want to be careful not to erase my marks. Oops, I already erased a little bit. I didn't want to. Okay, so it says what percentage of the data is above 10? Well, be careful here. We don't need our 68, 95, 99.7 rule for this. We know that 10 is the mean. And so 50% of the data lies below and 50% of the data lies above. So that was actually a little different problem. Just making sure you understand what the mean, or where the mean is, and what percentage of the data is above and below. If you look at E, what percentage of the data is below 4? So that's over here. Well, 4 is 3 standard deviations below the mean. We know that 99.7% of the data goes from 4 to 16. Well, that means that 0.3% of the data would be out here. And again, this is symmetrical, so there should be the same amount or the same percentage of the data on each side. So we want to divide 0.3% by 2, and we get 0.15%. And that's going to be it for this video.